Hi, in this video, I'm going to show you how to expose multiple Kubernetes application on Amazon EKS using single ALB ingress. As you see in this PPT or in this diagram, this is a design diagram or flow diagram of my demo. This diagram depicts, how does this flow setup works. Yeah. So as usual in my video, I'm going to show you the my complete demo into two parts. In the first part, I'm going to explain you saying how does this setup works with using this design diagram. In the second phase, I'm going to show you how to set up these complete workloads, and also show you, how does this complete workload works as an example demo. Yeah. So all right. So before I walk you through the first step of the demo, that is how does this works, a kind request, please do subscribe my channel. That would really encourage me a lot. So with that note, let's directly jump to the first part of the demo. Yeah. So so as you see in this PPT or in this diagram, so this is a purely design diagram, which will depicts how does how you can expose multiple application which is hosted on a single Amazon EKS cluster with using single ALB ingress. Okay, so that's the main motive of this demo. So this diagram, this is a simple design diagram, I can say, which will depict that. So basically, what we're gonna do in this video or in this demo is we're gonna create an Amazon EKS cluster in my AWS account. So I have already have an my AWS accounts, which becomes a prerequisite for this demo. So in that AWS account, I'm going to create a Amazon EKS cluster in my US East region of my account. That EKS cluster going to be sit in a VPC. So that's where the outer box depicted as a VPC. Nothing but it's a a virtual private cloud where your Amazon EKS cluster going to be hosted, right? So and if you come back to the next, if you come inside to the next next boxes, you see there are green, blue, and yellow boxes, okay, which depicts availability zones of the VPC. Okay, so that's where our EKS cluster, it will be hosted across the availability zones. Okay, and within the EKS cluster, we're gonna have the availability set. Generally, the availability set is nothing but a collection of EC2 instance which scales ups and scales downs based on the certain rules that you configure on the auto scaling group rules, right? So this auto scaling group is nothing but it contains a EC2 instance nodes. The EC2 instance nodes will be hosting the the application pods, and the application pods are grouped together, frames a thing called service, and that service will be configured in a ingress with a, and in ingress we're going to define a certain rule saying whenever client request for certain services from the internet or from the browser, and this is how the ingress has to be behaving. Okay, that's where the rules definitions will be defined in the ingress. Yeah, all right. And finally, this ingress is exposed in front of ALB, that is the AWS load balancer services, right? And with using the AWS load balancer services, it gonna expose a fully qualified domain, right? That is FQDN, and that FQDN is acting as, here I'm showing only HTTP, but in the production you can you can set up as HTTPS as well. So finally, once your application is hosted on Amazon EKS cluster from the scratch to end, if the business or if any user goes and hits this URL, that is something like this, https:/, then your ALB FQDN /green, right? It's gonna get you a green application, nothing but the application which is hosted on a same Amazon EKS cluster. Similarly, for yellow, if the if the user is trying to hit the URL something like this, that is yellow, the request going to pass through this ALB and reaches the ingress. In the ingress, it will identify the rules and it will point to a yellow service, and that's where the response will be given as a yellow banner, right? And that's where you see, so this green and yellow is nothing but it depicts a two flavor services that is being hosted on the same Amazon EKS cluster as a container application, but being exposed, right? So we are exposing these two applications within using a single ALB ingress. Okay, so that's a peculiarity of that's a peculiarity of this demo, and this gives a certain advantages. Okay, all right, so this is how the flow works. If I can reiterate, so we're gonna create an Amazon EKS cluster that is being hosted across the availability zones, right? And also the auto scaling groups, and within the auto scaling groups we have the EKS nodes, and the EKS nodes, we're gonna deploy the container applications. Okay, and that container applications will have the services, and services will be configured in the ingresses, and Ingress is is front-ended by the ALB FQDN, and then when the business consumes that FQDN like this, it's gonna serve the respective applications. Okay, that's the main motive of this demo, right? And along with one more thing I'm gonna show you, which is a very unique thing of this demo, is we're gonna create the custom images with using our own Docker file. We're gonna define our own application, just example.index HTML file, and also we write our own Docker file. We build the Docker image, we push the image into the Amazon ECR. I'm gonna show you all those steps, and that Amazon ECR images will be used to deploy an application in this Amazon EKS cluster. Okay, so that's the additional capability of this video, I can say, or that's additional feature that I'm going to show you in this video. All right, so with that notes, let's we have completed the first phase, that is how does this setup is been done. All right, let's go to the next phase. Okay, so as usual, to make the the demo very clear and up to the point, and to cover all the scenarios of the demo in a single stretch, I have articulated all the commandlets that you need to run from your CMD or from the PowerShell. I'm using Windows system, that's the reason I'm telling like you will use CMD or PowerShell. But if you are using some other flavors like Mac or some other thing, maybe you need to use respective terminals. Right? All right. So so this is the commandlet file which depicts which has already written all the steps that we need to run has been documented. And if we follow these steps one after the other, we're going to achieve the required aim of the demo. Okay, and this file will be uploaded in my GitHub repo, and the GitHub repo link will be shared in this video's description. Maybe you can find this file from there and use it when you are learning from this one. Okay, along with that, I have an color app.yaml. So this is the Kubernetes specification file, which depicts which defines what is the namespace, what are the deployment, what are the services, and how does the ingress have been configured. Okay, when I deploy this application, I will explain you, I will walk you through this all the configurations specifications. Okay, and also we have a IAM policy. This IAM policy will be used by EKS cluster to create a ALB or to interact with the ALB and all. Right? All right, so this is the policy we're going to also create during the dynamically during running all these commands. Okay, all right, now let's directly jump to the this demo. So in this one, I'm using Windows PowerShell. As I said, you can use Windows CMD as well to run these commands. Right? So before you run this command, there are certain prerequisites. Okay, so in that one, the first prerequisite is you should have your system installed with the eksctl, which is EKS command line tool utility. That's where the acronym is all about. You should have eksctl installed in your system so that you can use that eksctl utility to create an EKS cluster dynamically. Then you should have AWS CLI installed in your system so that you can use the AWS CLI commands to interact with your AWS accounts for interacting with the ECR and all. Then you should have helm installed in your system so that you can use the helm commands to create the required configuration on the EKS cluster. That is to configure the ALB controllers and all. Right? All right. So these are the prerequisites for this demo. All right. So being said, I have already configured all these prerequisites in my system, and henceforth I have opened my Windows PowerShell. This is the Windows PowerShell, and I have run the command called AWS configure. Once I run this command, it is asking me access key, secret key, then output, then what is the reason, right? So if you see, I am keeping all those configurations default. And one more thing, I have admin privilege on my AWS account. That's the reason I don't have any permissions related issues. Make sure that you are also well known about all those prerequisites as well, right? Okay, so with saying that, I have run this command saying like eksctl create cluster, and then we are giving the name of the cluster, node type t2.large, node 1, minimum node equal to 1, maximum node equal to 2, region equal to US East, right? And the zones, right? I was also talking about the zones. So here we have defining the zones like US East A, B, C, right? And that's the reason I have depicted here diagram saying like this cluster is being spread across the availability zones, right? So that we achieve the required highly availability feature of the EKS cluster, right? All right, so that's the command I have run here, and eventually this indeed it creates a EKS cluster in your AWS account. This is a very lengthy process because it takes nearby 15 minutes. If you see here, it started at 13:55 and end at, if I go down, it has taken, at almost, like it has end as, 1412, which is nothing but, again, it has taken nearby 17 minutes to spin up, right? And that's the reason I have already pre-created this, EKS cluster. And this is my AWS account. I am currently in North Virginia region, and this is a Amazon Elastic Kubernetes Services page. If I open this, my EKS cluster status is active, and that is the EKS cluster which I created from here, right? So with that said, let's go to the next one. So here, the next command is, so these are the commands which will help you to interact with the eksctl utility. With using the eksctl utility, you can interact with the, Amazon EKS cluster. Okay, so that's the reason I have segregated that part separate in this help file. All right, I'll go to the next one. In the next commands, we need to follow the next commands to, do the, the next operations. Okay, the next operation is, as I said, we're gonna create our own, we're gonna create our own Docker images, and we publish this Docker image to our Amazon ECR. And from the Amazon ECR, we're gonna point those Amazon ECR link in the specification file, so that, the deployment happens directly from that image. Yeah, I'm gonna show you like how we can do this one. So with that note, let's first go and follow the commands. That is the first commands, AWS CLI to create the repositories. Okay, so first one, let's create the repository. We are creating two repositories because, we need one repository for creating, one application. Okay, so here we are going to deploy two applications in the already created EKS cluster. So I'm going to run this command. All right, so this command, what does this command does? This is a AWS CLI command which creates a ECR repository with the name green, right? And here you go. So it's a very quick job. It has created a ECR. If you go to the ECR and go to the repositories, in the private repositories, because this is our private repository, I'll go to the private repositories. Where is the private repository? So let me refresh so that we can see the repositories here. Yeah, so here you go. We go to the repositories. Here is the repositories. Okay, so in the repositories, right, so these are all private repositories, and we have the green bean created, right? Similarly, let's create the another repository, because we are using these two different repositories to store, the Docker Hub image. Okay, so as the namespace, we in this ECR, we're gonna store Docker image belongs to the application green, and yellow we're gonna store Docker Hub image belongs to the application yellow, right? All right, so that's where we are done with it. And then the next command, I have just articulated, what is the reason that we are using. This is my account number. And finally, how does the repo URL looks in? So this is the repo URL, which is normally it follows a syntax which is something like this. That is your account number, dkr.ecr, then the reason, then amazon.com. So if you go to the repositories, that is ECR repositories, here you go, right? So we have the repositories, and if you see the URL, so this is where I was talking, right? So if you see here, if I open this, currently there are no images, and the URL which I was talking is about the, from the here to here, right? All right. Okay, so we have set the first component, that is creating the Amazon ECR, right? We're gonna go to the next step. So in the next steps, we going to get the password, because this is a one-time job. And this is also a purely demo for learning purpose. That's the reason I'm gonna get the password of ECR dynamically in this in this command. But in the real time CI/CD or real time, or in real time, for example, if you are performing using the GitOps or maybe in any other method, right, with you or any other DevOps methodology, maybe you need to store this password somewhere else in a secure way and retrieve it from the secure way and use it during the during the image publications, right, or image pushing purpose. All right, this is a very encrypted password which I have got right now. We're gonna use this password to do the next operations. What is the next operations? We're gonna authenticate the ECRs. To authenticate the ECR, I need to follow these two commands. So I'm gonna do that for now. So first, let me put that command first. I'll just copy this command again. So what is this step does all about? This is the step where we are authenticating this command line session with the the Amazon ECR which we have created just above, right? I'm going to copy this password and I'm going to replace that password somewhere here. So we'll just replace all this. Why do we need to do this? Because with this you are authenticating this session. so that the image can be published from this session to the Amazon ECR. Without this, you cannot push the image to the Amazon ECR, right? That is a elastic container registry. All right, so I'm going to store I'm going to store that password here and enter the command. So basically what does this command does is AWS ECR, this is the reason Docker login. In the sense, this command is leveraging this Docker utility, or from this session you are authorizing the Docker to have a connectivity to the Amazon ECR. Okay, so basically this command is meant for authorizing the Docker. Why we are authorizing the Docker? Because we are going to create a image, and that image needs to be published in a upstream ECR. Okay, that is a private repositories. Okay, all right, so let's go to this one, and let's complete the another command. So finally it is taking some time to authorize the Docker. So finally we're going to see some message saying like you are authorized or login successful. Okay, so we need to do this command for 2 times. If you see this, if you follow this command, so we are running this command 2 times, one time for yellow and another time for green. I'm not going to change the password again. I will use the same password, but I'm going to change this yellow to green. Here you go. If you see this message, login succeeded, in the sense you have authorized the Docker to log into the repository or ECR type yellow. Now let's do it same for the green as well once. So this is green. I am just running the same command because the password is same and the rest syntax is same, right? So it's again follows the same syntax. That is AWS ECR reason, Docker login, user is AWS, this is the encrypted password, which is same password we need to use. And finally one going to change is the final URI of the repository going to be changed, and that URI also following the same pattern but ending with green, and that's the reason I am using the same command which I have ran above, right? And if you follow this command, you're gonna get the similarity. Okay, all right. So it's gonna take a few more minutes, and with that we will be completing the step to authorize Docker to publish the image into the upstream ECR. When I say upstream ECR, is nothing but the this is a private repository which is created in a Amazon Elastic Container Registry, right? So it's gonna take some more minutes, and we go to the next steps. In the next step, what we are going to do? So this is the step where we're gonna build our own Docker image. Nothing but we build our own application wrapped as a Docker image, and that Docker image we will be publishing in a upstream ECR which we just now created. Okay, and that's the reason we're gonna do something like this. Okay, so for this case I have already created a folder. That is one folder, yellow folder has application data belongs to the yellow application, and green folder has the configuration file like Docker file, and the application files within the green folder belongs to the green application, right? And that's where, so we're going to run these 3 commands per each application, so that we build it, we tag it, and we push it. All right. Okay, so let's wait for this authentication to complete. It is taking indeed some time. Yeah, and then we're gonna use the we're gonna do the next commands. Okay, so before this runs, I'm gonna explain you what is those folders all about, right? So within this path, if you see, this is I'm currently in the path, right? So if I can go, so currently I'm in this path, that is EKS multi-application. Within this path, I have created I have kept the folder belongs to one application, that is a green application folder. Then you have a yellow application folder, right? Both the application definitions are same, but underneath the index.html file is different. Now what I am going to show is in this folder we have created one Docker file which actually creates an image of your application, right, with using something like this. If I can open this file, so if I can open this file in my editor, that is Notepad++, and then I'm going to explain what does this Docker file definitions tells about. Okay, if you see here, from in the sense we are pulling some image from the public ECR image, and which image we are pulling, the Nginx version 1.2-Alpine image, which is nothing but a kind of OS you can think about. Okay, so we are pulling that image, and in that image we are creating a directory underneath this path, that is user share nginx html green, and in that one we are copying the index.html file which is there in the folder. So the copy command will copy the file present in the local path to the image image path. Image is nothing but, what do you mean by image? Image is nothing but, it's kind of you can call it as it's a file. Through that file, you can create one more machine. You can think something in layman and try to understand, something like that. Yeah. And finally, we are exposing the services on the port number 80, which is a HTTP, right? And if I can open the index.html file, it's a HTML file, as the extension says. It's the HTML file, which just creates a background. Okay, when you run this HTML file, you will have a HTML page with the all background green, right? All right, so that's the definitions being kept in green. Similarly, in yellow, we have the same Docker file, but this time it points to the yellow.index file. Okay, similarly here we are using very simple image, that is Nginx Alpine. We are creating the path, something I explained, and then again we are copying the yellow index.html file within this path within the image, and finally exposing on the port number 80. So if I go back, and this is our yellow index.html file. So if I go to this one, so this is a yellow index page. Okay, this is very purely simple file. So here you are also learning how to build Docker image and publish into the ECR. Okay, so you are building Docker image about what? You are building a Docker image of your own application. Okay, that's the specialty of this this part. Yeah. All right, indeed it is taking some time. Maybe I might need to okay, so let me check if the connection is right. So I need to switch the network, maybe because of the network connectivity slowness, maybe it will have the problem. So I will just connect it. Okay, so yeah, all right, so I have switched the network, which is very fast indeed. So I'm gonna say, here you go, right? So unfortunately we have succeeded. Maybe I will run the same command again so that I'm double sure, right? So we are executing this command, then then it is using the same format. Basically, why did I do this? Because while processing this one, I have switched the network, right? So maybe it may not, it may be losing the metadata, for example, right? That's the reason I have rerun it. Okay, that's for security. Okay, all right, so login is successful. Let's go to the next command. Okay, so and I have also followed you I have explained the the respective folder structures. Now let's go and build those images, that is yellow application image and green application image. First let's build yellow image. So for that case, what I need to do is I need to do a cd, right? So I'm going to cd to yellow. Why I'm cding to yellow? Because this is the place where the Docker and index file is there, right? And that should be the cd, that should be the directory path where you can run the Docker build. Okay, all right, so I'm gonna run this command docker build yellow, right? So what does this command tells? It tells hey Docker, go and build the image as per the definitions present in the Docker file belongs to this folder. T is nothing but folder, in the sense, in which folder? Yellow folder. In the yellow folder we have defined something like what kind of image you need to build, right? And that's where it is doing right now. If you see, right, it has started to build. All right, so where were we? So right now I have run the command and it is trying to execute the commands. Okay, all right, so basically it is building the building everything. So let's wait for this to complete. If you see here, the build has finished, in the sense it has successfully built the yellow image. Okay, once build is successful, it will come out of the this loop. Okay, let's wait for that to complete. It has finished. Okay, and here you go, right? So Docker scan, in the sense image one. Okay, all right, the build of the image is fine, in the sense it has successfully built the image right now. Maybe I can show you that image has been built here. So this is my Docker, this is my Docker desktop, and I'm going to show you that that image is already built here. So it's taking some time, maybe it's loading up. Meantime, let's go to the next commands. The next command is what we are doing. We are tagging that image. So how do we tag that image? Which using the command docker tag, then yellow latest, and then finally pointing to the ECR URL. Okay, and let's copy this command and run the command. Next one. All right, so let me copy this command and let's run this one. So it's a bit lengthy one, so you need to be very patientful and so that you will understand the end-to-end thing, right? So right now we have tagged it, and in the meantime, if I can show you the images, I'm going. So this is my Docker desktop, and that's where I was able to run the Docker commands. And if you see, yellow has been successfully created. All right. All right, so with that note, let's go. We have just now tagged it, and now let's publish that image into the, or let's push that image into the upstream ECR, that is a AWS ECR. All right, so let's push it. Right, if you see here, if I go to the LO, right now there is no images. You should see some image here now. Basically, what it does is, from this local Docker hub, you are pushing that image into the upstream, ECR. It takes some time, and it's also a bit lengthy, push as well, because the size of the image is a bit bigger, right? Once the image is successfully pushed, it will come out of the the cursor. Okay, that's where I'm waiting. So here you go, right? It has successfully pushed. Now if I refresh here, we should see our custom image being pushed here. Here you go, your image is being pushed. Okay, congratulations. Let's go to the next steps. And in the next steps, we're gonna do the same for green application as well. For that case, I need to do the CD to the green. So all right, so yeah, I need to do the CD dot dot, and then run this command CD green, right? Okay, so CD green, let me go back to the CD green. So I have to do the CD back and then go to the CD green. So this is the Docker file. Okay, so in this one, we're gonna run the same commands here. We first need to build the Docker image, and then we're gonna push that Docker image into the ECR, right? So let's build the Docker image. So basically, if you see here, right, we have did the CD and then Docker image getting built. Here you go. It was very quick, and the Docker green image is also been built. Now let me go back here, and yeah, here you go. The Docker image is also been built. All right. So whatever images I am getting built, so that is being presented here. Okay, this is just a UI. Okay, you can see what is happening in your local Docker hub. Right. All right. So let's since the image is built, let's do tag and push it into the upstream ECR. So if I go here and do the tag, we are done with the tag, and let's do the Docker push. All right. So I'm gonna do the Docker push as well. So here you go. I will just scroll it up so that you can see it clearly. Here you go. It's pushing very fastly. Let's go back to the green, and we should see some image under green repository as well. So we'll go to the green, and here currently no image, and it should be available in seconds. So if you see here, all right, let's wait for a couple of seconds and let it finish the image pushing into the upstream green ECR. And if I refresh it here, so we should see some image here. Okay, that's where I was waiting here. So let's wait for, here you go. The green image is also been pushed into the upstream, right? Okay, so we are done with the prerequisite. Now we are in the step. Okay, we are in the mode to host the application and realize the exposing multi-application on a same AWS or Amazon EKS through a single ALB. Okay, so that's where the step starts from here. Now I'm gonna show you helm. So helm is mandatory here because we are using the helm commands to to configure the multiple configurations of the EKS. So that's the reason I'm just checking the helm version here. So this is my helm version for your information. And then I'm just explaining what is the Kubernetes Ingress. Okay, so Kubernetes Ingress is an API object that provides routing rules to manage the external users to access the services in the Kubernetes cluster, typically via HTTP and HTTPS. Okay, so that's where I have explained here, and let's check our EKS cluster. So this is the command I'm running, that is eksctl get cluster. This is my cluster name, that is a multi-app ELB. That's my cluster name. What is this command does? This is a eksctl command which gets the status of our EKS cluster, right? So that's where I'm running this command. So okay, so the command is taking a bit time. This is unexpected. Okay, all right. So that's where just to check the status of your cluster, and the next step is we're gonna create IAM OIDC provider, right? So let's create that. Hope this gets completed successfully. So let me run. Here you go, right? So if you see here, the status of your cluster is active, right? All right. So that's what we needed, and let's run the next command to create IAM OIDC provider. So I will go to there and run this command. So active, not active is not required. So I need to copy this correctly. So I'm gonna copy this command. Yeah. So let's copy this command. So basically what we are doing is we are using the eksctl utility eksctl utils associate IAM OIDC provider. Okay, so basically it's going to create a IAM IODC provider on EKS cluster. This is the EKS cluster, and it was very quick job it has created. And the next command is, I need to do a cd back, and we're going to create a IAM policy. Why do you are going to IAM policy? Because I need this IAM policy for my EKS service account, and that's the reason I'm creating a IAM policy. And that IAM policy definition I have explained you here. That's a IAM file which is kept under the path I have kept this path here, that is IAM policy, and it contains something like this. Okay, here we have allowed certain permissions on the EC2 and ELB. Why? Because these are needed to set up the ELB, right? ELB that is required for Ingress, right? It's a big one. Maybe you can have a walk through this code later, because anyways I'm going to share you this file with you, and you can have a deep digger down in this one. Okay, you can dig down into this deeper. Yeah. All right, so the policy is also created. Let's go to the next command. So where is our command helper file? So this is our command helper file. The next one is we need to create a service account and associate a IAM role to that service account. Why are we doing this? Because that service account is searched within the EKS cluster, and being sitting within the EKS cluster, it should have the capability to interact with the AWS account, so that it can create a ELB, ALB, right? And make or authenticate the ELB to invoke the underneath services, right? That's the reason this is very important step, and we're gonna create now. So the command tells eksctl create IAM service account. This is the cluster name. This is the namespace. We are using the kube system, and the name of this service account is AWS Load Balancer Controller. The policy is nothing but the policy which I have used here. So that policy ERN has been given here, right? And the overriding existing service, and then approve yes. All right, so I'm gonna hit enter now. So by hitting enter, what I'm doing is I'm authenticating to run this command. Okay, I'm allowing this command to run. So this command going to create a IAM service account within our EKS cluster of name multi-app ELB, right? Okay, so let's go to the next command meantime. Okay, so we are done with this. Next command is we need to configure the cred config map in our EKS cluster, right? So how do we do that? So we need to run the kubectl command. So right now we are starting to use kubectl command. Generally people will call it as a kubectl. I don't know. There are so many things people will try to call this one. So we call it as a kubectl. So kubectl apply k, and we're gonna use the public repository to create a target grouping, group binding, and the creating the required credentials. All right, so our controller is done. Load balancer controller is been configured. Let's create a CRDs required on our EKS cluster, right? Which is required for ELB to work. So I'm going to create this. So basically kubectl apply, and before you do the kubectl apply, make sure that you are sitting in your Kubernetes cluster or your EKS cluster profile, or else it might configure in a different profile as well. Okay, that's for your information. So let's wait for this command to get run, and then we're gonna check the credentials. That is kubectl get CRDs credentials. Okay, so let's wait for this to complete. Indeed, this is a bit a lengthy one, because while running this command, it is reaching to the GitHub, that is a public GitHub, and then it is retrieving the configurations from there, and finally creating the configurations in the EKS cluster which we created, right? All right, so we are very close. Before that, while that is running, I'm going to explain you the next steps. We're going to get the CRDs credentials, then we're going to update the helm repositories, and finally we're going to create a ALB. So this is the command which will create a ALB in front of your Ingress. This is a very, very important step, right? Okay, so let's see if our bindings are being created, right? If you see here, our bindings are being created, creds are being created. Let's check our creds. So kubectl get creds. Let me check this command and check out the status of our the above configuration. So if you see get creds, here you go, right? So all those credentials are being listed here. One is the ENI configs, Ingress class params, security group policies, target group bindings, right? So all those CRDs are being configured. Now let's do the next command. That is, we are using the helm commands. For this case, I need to add the EKS repo to my local helm repository. It's already done. That's the reason it is telling now EKS is, EKS repository is already there for my helm. That's the reason it is skipping. Okay, now let's go to the next command. So next command is very, very important command. It's a tiebreaker command, I can say. And this is a command which actually binds ALB, right? ALB is an external service. That ALB will be binded to your EKS cluster. Okay, this is very important command. Helm upgrade AWS load balancer controller. So we are going to create AWS load balancer controller now. From the Helm repository, EKS AWS load balancer controller, the name, in the sense we're going to host this configuration in a kube system and set, what we are setting the properties in the cluster name, we're going to make the cluster name equal to multi-app ELB. Then the service account create equal to, we're going to make it false. And the set service account is nothing but the service account which we created above here. We're going to use that service account name, right? So this name should be matching to the service account name that you have given here. Right, if you see AWS load balancer, right, so here AWS load balancer controller, right, and the cluster name should match to our EKS cluster name, right, and these are the important parameters that you need to pass while running this command. Let me hit it, and we're gonna create load balancer controller now, right? So it's checking that AWS load balancer controller does not exist. It's going to install now. So what actually this command is doing, in a sense, it's gonna create a AWS load balancer controller for us. Right? All right. So it takes a couple of minutes. Then we're going to go to the next system, next command. So the next command is, we are going to roll out the status of the deployment. That is AWS load balancer controller deployment. Basically, when you deploy these many Helm commands, Helm command generally do some certain deployments on your EKS cluster, right? Here you go, right? So it has taken some certain minutes and the deployment is successful. If you see here, right, this is the name of our deployment, the namespace is kube system, the status is deployed, and this is the deployment name. Now let's roll out. To roll out, we're going to run the command kubectl name, rollout status, okay? And if you see, the status is rolled out. We are done with it. Now the final step, okay? Now what we did is, now you have decorated everything. When I say decorated, in the sense, you have configured your EKS cluster, right? And you have configured the required prerequisite on the EKS cluster, right, which includes CRUD configurations, ALB load balancer configurations, right? Everything has been configured here now in your cluster, and you also hosted AWS load balancer controller on the EKS as well, right? Now the time has come to deploy these services and configure the ingress, right? And that's where I'm coming now. So let's do that by running the command kubectl apply color app.yaml. Before I run this command, I'm going to quickly walk you through the content of this color app.yaml. The color app.yaml, as I said, this is a Kubernetes specification file. It's a YAML format. In this one, we're going to create nearby 5 or 6 services. One is, we're going to create a namespace called color app, right? And then we're going to deploy. We're going to deploy 2 applications. One is green app, another one is yellow app. So that's where, so app is version 1 and the deployment kind is deployment, and these are the metadata, right? The namespace is color app. So every deployment I do down the line, targeted to the same namespace called color app, and the label is green app, yeah? In the specification, so we are using the selector method and match labels equal to green app. Replica set, in the sense we're going to create a two parts of this deployment, out of this deployment. And in the template, metadata label equal to green app, right? And then finally in the specification, so this is very important part, where actually, the deployment of this application happens by pointing to the AWS ECR, right? If you remember earlier, we built our own image and we pushed that image into the ECR. That's where it is coming. So the container is being built now with a name called green container. If you see, the name of the container is green container. And the image is, it is targeting to the image which is sitting in our upstream ECR, right? And image, we just need to give the URL, okay? So, and that's all. So the Kubernetes, this specification file will download that image from there and it will create a pod out of it. And the exposing happen on the pod 80, okay? And then resources, okay? So in the resources, in the sense, within the autoscaling group, when the deployment happens, you are specifying, this part has to have minimum memory of 10 megabytes and CPU of 200 milliseconds cycles, okay? So that's where the definition is there. Likewise, we have the deployment for green as well, which is the same replica. I'm not going to walk you through this one. So for yellow app, it's again the same. We are pointing to the yellow app image. and the resource limitation configurations. Then finally, we're going to create a service for each of above deployments. The kind is services. The metadata is, again pointing to the same color app namespace. The name is green service. Labels are green apps. Annotation is something like this. So this is very important. You need to note that is green index is the kind of health check path we are configuring. And in the specification, we are making the specification as node port. Then the selector is nothing but which app it needs to select. That's a green app. Since the service is green, we are pointing to a green deployment. App is nothing but deployment. The port is again belongs to the port 80 and target port equal to 80. Right? This is for green service definition. Similarly, for yellow service definition, it's a replica of above. But here app points to the yellow app above. And index points to the yellow index. Right? Okay. Now we have the two services. Now let's configure the ingress. This is very, very core part of the demo. So here I'm using the API version equal to networking.kubernetes.io/version1, kind equal to ingress. Then the name of the ingress equal to color app ingress. The namespace is equal to color app. Then the label equal to color app. Yeah. And in annotations, these are very, very important annotations, which defines the working or functionalities of the ingress. One is Kubernetes Ingress class equal to ALB. It is the schema is internet facing. Targeting type is equal to IP. Health check protocol equal to HTTP. Health check port equal to traffic port. Then the health check entry equal to 15 seconds. Health check timeout equal to 5 seconds. Then the success rate code equal to 200. The health check threshold count equal to 2. Unhealthy equal to 2. Right? So all these annotations have been defined for ALB ingress kubernetes.io parameter. Yeah. And within the ingress, as I said, the rules defines based on the if user is hitting this path, go to this resource. So that kind of mapping will happen within the rules. So under the rules, we are having the HTTP kind of rules, and in the path one we have defined two paths. One is yellow path, and the path type equal to prefix, and the backend of this path is equal to belongs to the yellow service, and to reach this service on the port 80, that is HTTP port. Similarly for green, it's a green path and the prefix green service and reach on the port number 80. So this is the end-to-end definition of the the color app.yaml specification file, which I'm going to deploy into this EKS cluster, right? And that's where this command does. I'm going to hit this command kubectl-f, then color app, right? And it eventually has to supposed to create all those resources. It should create the namespace. If you see, follow this one, apps, services, then ingress. And here you go, the ingress is also successfully created. Okay, so we are almost done with our required configurations, which means okay. Now what we do is let's check the status of the ingress by running this command. If the ingress status is very healthy, then it means that you are done. So how to get the status of my ingress? That is kubectl get ingress, and the ingress name is color app ingress, and the namespace belongs to the color app. Right? Here you go. If it is returning address something like this, which means that the deployment of your ingress has, and the deployment of our application, service configurations, ingress configurations had went very good or as expected, then congratulations. Okay, so we have completed the deployment as expected. Right? Now let's go to the next commands and try to get the URL that we need to check to to test this demo. Right? So I'm gonna go do that now. So for that case, I need to run this command. So I'm gonna get that URL first. To get the URL of your ingress, maybe you can directly get the host address. The other method is you can do a kind of a code trick and get the URL path. That is kubectl get ingress color is namespace equal to color app. Output in the JSON format, get the host name. Right? So once you get this host name, so now we are ready to test our application. So this is the ALB endpoint. Okay, so if I go to the my account, so we have successfully done everything configurations required for this one. Now it is time to test it. Okay, so before test it, I'm going to show you that ALB has been created. So for that case, I need to go to the resource called EC2, and then where we can see this ELB. So I will go to the EC2, and we go to the EC2 service, and in this one we're going to check the ELB. In the ELB, we should see the URL of the the load balancer. So if I go to the, where's the load balancers? Okay, so here the load balancer. I will go to this load balancer. Right, so I'm going to load balancer, and we should see a load balancer which we have deployed just now. Right. All right. So right now we have done with this one. Now we are here. That is to test the multi to test the expose of multi application. hosted on a single Amazon EKS cluster with using single ALB, right? That's the specification. So if I go to the load balancer, I'll go to the load balancer. Okay, so I'll go to this one and we should see one load balancer. Here you go. All right, so our load balancer is sitting here and it is working fine. So if I get, so here you go, our DNS name is this one and the listeners are this one. I will just expand this one. It is listening on this one, right, on port number 80 and the monitoring integrated services, right? If I open the integrated services, everything, it will show everything, right? So what I mean to say this one is, once you have successfully deployed, then if you see the, load balancer, which means that, your deployment has been successful, right? I'm going to expand the next page and the time to test now. So to test that, I need to hit the endpoint, right? So for that case, let me type, let me put this command, okay? I'm just put this, okay? So how to do is, we just need to put the endpoint, which is we have retrieved from here. Just copy this, yeah, and go to the here and try to enter it. I'm just entering the bland, okay, without using the /. So why it does not returns anything? Why? Because we have not defined that in an ingress, okay, and that's the reason it says page not found. But if you go to the ingress, in ingress we have shown that with using if I can go back, so Control V and use yellow, for example, yeah, right. Now it should point to the yellow app. Let's see if it retrieves the yellow app. Okay, so here you go, right? So our yellow app is retrieved. So this is nothing but the HTML file which I have kept in the yellow file. So if I go to this one, so this is the file which is getting printed in the, which is getting retrieved now in the as an application which is hosted on the Kubernetes, right? So this is one path. This is one application, for example. Now let's go to another application with the name called green, for example. So I'm going to change this number to green. And we should see a green page now. Here you go, the green page, okay? So congratulations, okay? I have successfully shown you the things to be shown in this video. Finally, a quick recap, okay? So in this one, we have seen, how to create a EKS cluster. On top of the EKS cluster, we have seen how to configure the, the required service account, creds, then configure the AWS controller, right? AWS load balancer controllers, then how to deploy the applications. I have also walked you through the YAML specification files, and I have explained how does the deployment happens, how does the services are being configured, how does the ingress have been configured, and finally I have also show how does this ALB looks in the EC2 page. And finally we have tested the accessing the two application which is mentioned in this in this diagram. That is, if you hit the green, you are getting green page. If you hitting yellow, you are getting a yellow page. Yeah. All right. So I have shown you the things to be shown in this video. I can't request finally. Please do subscribe my channel. That would really encourage me a lot. And finally, thank you very much.